Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet. Today's host is Tony. He is their Vice President of Sales, and he'll be presenting today. If anyone has any questions, please feel free to submit them in the question. Tony will answer them at the end of today's presentation. Tony, thank you for being with us today. I am finished for now. You can go ahead and
Excellent. Thank you. Hello, everyone. Again, thank you for joining today's webinar presentation. The focus of today's presentation will be on 60 gigahertz millimeter wave technology and products that IgniteNet offers in that, for those solutions, as well as a couple of other products that are kind of unique and fit in to the millimeter wave, like point-to-point, point-to-multipoint type of solutions. So we'll just get started. Brief introduction on 60 gigahertz. It's part of the V band, so that's anywhere between 40 to 75 gigahertz. It's also known as millimeter wave. People call it millimeter wave all the time. Adopted as an unlicensed frequency band in the US by the FCC around 2001. And really interesting is early last year, the FCC recently added 7 gigahertz more spectrum, so frequencies from 64 to 71 gigahertz. We're also included in this unlicensed frequency range for millimeter wave. And I'll talk a little bit about why that's important later when it comes to distance and rain fade and oxygen saturation. Applications for this type of product are predominantly outdoor point-to-point and point-to-multipoint, but there are indoor applications as well. There's a lot of companies creating 802.11ad products for, say, wireless controllers on gaming systems and other things where higher throughput and higher speed is required, and much shorter distances with direct line of sight. And this frequency band is opened or unlicensed in a lot of different countries worldwide. And we have a little regulatory breakdown here that shows the US and Canada, basically Mexico also following FCC rules. And European Union, South Korea, Japan. So we're selling these 60 gigahertz millimeter wave products in these markets all around the world. So the 60 gigahertz frequency band is really, really great for getting above and out of the way of 5 gigahertz. And those that are doing 5 gigahertz deployments know that in a lot of cases, there's a lot of noise with 5 gigahertz. There's a lot of interference from other different devices. If I turn my laptop on here at home, I probably see 30 different SSIDs from different, 5 gigahertz devices anywhere around this neighborhood. So 60 gigahertz gives us a little bit of a benefit here. It takes us out of that noisy 5 gigahertz frequency spectrum. It's still unlicensed, so you don't need to go out and get costly licenses to run this like microwave technology. The interference probability is very low, and it's low because, in a point-to-point 60 gigahertz, deployment, the beam width is around 2, maybe 3 degrees. So with a 2 to 3 degree beam going point-to-point, it's really unlikely that you are going to have interference from another 60 gigahertz device. The distance becomes a problem with 60 gigahertz where, we have max point-to-point distances around 1.7 kilometers. So it's just about a mile where you can go with a 60 gigahertz link, but it has to be direct line of sight. Unlike 5 gigahertz where you can have trees or branches or other things in the way, 60 gigahertz will require that direct line of sight. The spectrum crowding is very light. Like I said, it's not like 5 gigahertz. You actually couldn't open up your laptop and detect a 60 gigahertz signal unless you had some, add-on adapter that had a 60 gigahertz wireless card inside. So it's really good from that perspective. It's also really good from a security perspective. And again, 2.4 and 5 gigahertz signals, those will propagate 25 kilometers. That's what, like maybe 10 or 12 miles, even further for 2.4 gigahertz. A 60 gigahertz signal will only propagate about 2.5 kilometers, so maybe a mile and a half. So you can even reuse the same channel in the exact same direction a mile and a half down the road somewhere else in a different point-to-point link and not see any interference. So it's really good from that perspective because you can reuse the frequencies in the same, general areas as long as they're, say, 2.5 kilometers apart. The other thing is security-wise, again, because it's a narrow beam width and you're doing point-to-point or point-to-multipoint deployments, it's really hard for somebody to try to capture a signal and hack into a network and get into the backbone that way. Damn near impossible, I would say. So our products that address the 60 gigahertz millimeter market are called Metrolink. That's the product line that we have for these types of products. And I'll go through some of them, the typical applications for the products. The main, I guess, deployment that we're seeing from a lot of customers is in last mile access, providing gigabit speeds. And again, I'll show you the two different types of products where we can provide a gigabit of throughput over the air between links, or 2.5 gigs of throughput over the air between links. It's easy and quick to set up. You know, in this diagram, if you wanted to run fiber between the main building where you have your internet connection and all the buildings around them, you've got to dig up streets, go under concrete. It's really fast and cost effective to just put up radios on the rooftops. Again, as long as there's direct line of sight between them, and you can get that same connectivity between all these different buildings, whether they're commercial buildings or residential buildings. So point-to-multipoint and point-to-point in this last mile access is probably the #1 deployment scenario. Another deployment scenario is in security and video security. A lot of cities now are setting up, video surveillance throughout cities. 5 gigahertz signal, aside from the noise, is the bandwidth issue of being able to send, say, 4K video from multiple cameras throughout the city over 5 gig signals. It becomes a little bit of a bottleneck. So being able to set up point-to-multipoint 60 gigahertz connections to these cameras makes it a lot easier. So it'll be 4K video. There's probably 8K video coming after that. So there'll be enough bandwidth to send 4K video live streams from multiple cameras if you use 60 gigahertz. And again, you get away from the noise of 5 gigahertz. You don't have to worry about interference or somebody else, setting up another 5 gigahertz network that interferes with the one you've already set up. It's, again, secure between the two links. Really important for people that are doing, video surveillance type applications. So the other bullet point there mentions the 5 gig backup. I didn't talk about that yet. All of our 60 gigahertz products have 5 gigahertz radios built in as a backup. And that's in case the 60 gigahertz link goes down due to rain, or for whatever reason. Maybe the antenna is there and believe it or not, this happens, a bird lands on top of the antenna and the antenna gets moved by that 2 or 3 degrees and it breaks the link. The 5 gigahertz radio will connect, or stays connected, will actually start passing traffic if it senses the 60 gigahertz link goes down. So the traffic will stay and the link will stay running. You'll just go from, say, a gigabit or 2.5 gigabits of throughput down to 802.11 AC speeds, maybe 500 meg or less, depending on the distance. But at least the link can stay up and running until that 60 gig connection comes back. So that's another important feature that we have built into our 60 gigahertz products that you won't see in other vendors type products. Fiber extension, it's kind of like the last mile access one, where again, instead of ripping up the street to lay down fiber to go from one building to another building or in a campus environment, you can use 60 gigahertz millimeter wave radios to connect those buildings and provide that access. A lot of people do these deployments as temporary solutions while they wait for permits and other things to get the fiber laid. And then they either move them to other locations and repeat the same process, or they leave the 60 gig links up there as backup in case something happens to the fiber connection. So there's a lot of different uses for millimeter wave when you're connecting multiple buildings like this. Wi-Fi backhaul is another really good scenario where these products are being deployed. There's a lot of citywide initiatives going on now to provide citywide Wi-Fi, and backhauling the Wi-Fi access points using 60 gig is a really great way of, again, keeping the backbone of all the different access points up and running at a much higher speed and in a different frequency, so you're not contending with 5 gigahertz channel frequency noise and stuff like that. So building an infrastructure of backhaul for Wi-Fi access points is another really good application for 60 gigahertz millimeter wave products. So we have a couple of different products in this line. You'll see in any Metrolink product right now, you'll see a 35 centimeter dish and a 19 centimeter dish. So it's about a foot and about a half a foot as far as the antenna size goes. And they have different things. The Metrolink 60 line on the left provides 1 gigabit of throughput over the air. It has 2 gigabit copper ports on it. It definitely includes the 5 gigahertz failover. And there are versions that have connectorized antennas for the 5 gigahertz. A lot of customers said, look, we don't want to use the 5 gigahertz as failover. We'd like to use it for access. So they plug in, external 5 gigahertz antennas, and they can provide, omnidirectional 5 gigahertz Wi-Fi access at the same area where they're putting their point-to-point or point-to-multipoint connections. The max distance is about 1.7 kilometers, 1.6, 1.7 kilometers, about a mile really with direct line of sight. On the 19 centimeter version, it's a little shorter. It's about a half a mile, a little over a half a mile. That was our original version product. Early last year, we launched the Metrolink 2.5 version. And again, it has the same 35 centimeter and 19 centimeter antenna versions, but the throughput now over the air is 2.5 gigs instead of 1 gig. A question I get a lot is it full duplex or aggregate? These are aggregate bandwidth numbers, so it's 2.5 gigs of aggregate bandwidth over the air. We updated the port count on the Metrolink 2.5. We added a fiber SFP cage, so you can slide in a transceiver and you can run fiber directly at the pole. Used mainly for any installation where you have to go more than 100 meters, and you can't do that with Ethernet copper, so you can use fiber directly into the radio. You don't need a media converter any longer. The other port, instead of a copper, 1000 base T port, we added a copper 2.5 gig N base T port. So this is really great if you're using some newer N base T 2.5 gig switches and you have a 2.5 gig N base T port. You can get 2.5 gigs of copper, 2.5 gigs of throughput uplink speed to that copper port. It'll still work with a regular gigabit copper port as well, but there are a lot of these newer N base T switches coming out, so this port will take advantage of that if you have the switch port. The other things are exactly the same. The 5G failover, the connectorized versions, and the distances are all exactly the same as the Metrolink 60 for the Metrolink 2.5J. These are radios used for point-to-point connections. And they're also used as clients in a point-to-multipoint scenario. So for point-to-multipoint, we have 3 products. We have beamforming 120-degree AP. So what this is a sector antenna with a 120-degree by 30-degree antenna pattern. It has the same hardware as far as an N base T copper port and a fiber port. But this device is going to support up to 8 clients over 60 gigahertz. And it also has the 5 gig backup on it. The other one further on the right here, tri-band beamforming. So this is the Metrolink ML-60-LW is the model name. I think we'll talk about it in a little more detail. So this is kind of an interesting product because it's tri-band. It's the same 120-degree beamforming sector antenna. It has 5 gigahertz and 2.4 gigahertz. So these are used a lot when you're trying to create a client, going from, say, one building to another building, but also wanting to provide that citywide Wi-Fi access for, just regular people, or even for Wi-Fi access in that second client building. And then on the end there, we have the tri-band 10 gig Omni, which is a 360-degree, 60 gigahertz sector antenna. It's actually 3 individual 120-degree sectors to make up the 360 degrees. But it's an interesting product, and it has other, 2.4 and 5 gigahertz radios as well to make it tri-band. So it's kind of a cool point-to-multipoint type center point for any of these types of deployments. So we'll talk about the LW real quick. It's got a quad-core CPU. It'll give you 2 gigs of net throughput. Net throughput is a combination of the 60 gig throughput plus the 5 gig and the 2.4. This product with 60 gig will give you 1 gig of over-the-air throughput. So if you were looking for a low-cost client for really short distances to connect to a different point-to-multipoint sector, this Metrolink 60LW could perform that function. It has a max distance of about 150 meters, and it is tri-band. So the 5 gigahertz can be used as the backup as well as for client access. And there's also a 2.4 gig radio in there for client access. Both are 2x2 MIMO antennas with beamforming. So it's kind of a unique product. It has a lot of different uses. It could be used as a client radio going a maximum of 150 meters. It could be used as a point-to-multipoint sector, and it could feed up to 8 clients. Again, very short distances of about 150 meters. And it has that 120 degree by 30 degree, 29 degree beamform antenna pattern, which is really great. So a lot of our customers use these if they have short point-to-point connections, because they're very easy to aim with that antenna pattern. It's not a 2 or 3 degree beam, it's 120 by 29. So you can basically eyeball it at 150 meters and put up a really low cost point-to-point link. I mentioned that it's tri-band. Obviously, it's 60 gigahertz at a gigabit, and then it's 2.4 and 5 gigahertz for client access. And its max distance is about 150 meters. They got direct line of sight, 150 meters, no trees, no branches, nothing in the way of these antenna radios. We had some customers that were mounting them lower on the sides of buildings, and they couldn't figure out why their links were going down when delivery trucks were passing by the building and stopping in front of the building and breaking that link. So these guys should go high enough onto a pole or even on the building, but as long as nothing can interrupt the signal between the two radios. The other main product in point-to-multipoint we have is the 10 gig Omni. And like I said, this is kind of an interesting product. So this guy has 3 independent 120 degree beamforming sectors. So there's 3 radios inside to make up 360 degrees total. The over-the-air throughput on 60 gig is 2.5 gigs per client. It has a built-in 2.4 and 5 gigahertz radio. It has 8x8 multi-user MIMO antennas on 2.4 and 5 gig for this product. And it also has the same kind of connections as far as the gigabit copper. It's not an N-based T, it's just a regular gigabit copper. And it has a 10 gig SFP plus instead of a 1 gig SFP plus. And that 10 gig would be used, obviously, if you had 3 different sectors, each running at 2.5 gig, and then 5 gig and 2.4, you'd get close to that 10 gig net throughput. So you'd want to put a 10 gig fiber uplink port on this guy to get the full benefit of the throughput that it's capable of. So it's interesting for a lot of different ways. 60 gigahertz for backhaul and last mile. So you put one of these, say, every 150 or 200 meters throughout your city. You can then use any of the point-to-point radios for client access, and that could be to a residential building or a neighborhood somewhere else, or to another 10 gig Omni. You could use 5 gigahertz radios to connect to this. If you had some customers where, let's say, you were trying to sell gigabit service to one business, but then 100 meg or 200 meg service to a residential customer, you can do that lower bandwidth service using 5 gigahertz. And connect back to the 5 gigahertz radio in this 10 gig Omni. So we have a lot of customers that are mixing and matching those types of deployments where they're selling different levels of service with one main base station that they strategically position throughout a neighborhood or throughout a city. And this 10 gig Omni does that, and it has enough bandwidth with the 10 gig uplink to support all of those customer access requests. Little picture of the interfaces that we have here. Like I said, there's a gigabit Ethernet. It's not an N-based T port, and then it's an SFP plus fiber port. Just a quick overview of all the different point-to-multipoint products. The one we didn't talk about is the one on the left. This is the 2.5 gig beamforming sector. It's basically 1/3 of a 10 gig Omni. It's a single 120 degree beamforming sector. It'll do 2.5 gig over the air over 60 gigahertz. It has a 5 gig failover radio built in. It's not tri-band, so it won't have the 2.4 gig. So there are 3 options. And the reason for 3 is The Metrolink 2.5 gig BF will give you much longer distances than, say, the Metrolink LW on the other end. It'll give you 2.5 gigs of over-the-air throughput, but in some cases you don't need 360-degree coverage. You just need 120, and that's why this is a separate standalone product. As far as clients go for any of these, so a 10 gig Omni to another 10 gig Omni, about 150 meters. Maybe a better way to put it is any point-to-multipoint sector to a 10 gig Omni, or to an MLLW, 150 meters. Any point-to-multipoint sector to a ML 19 centimeter antenna, about 400 meters, 700 meters for the 35 centimeter. And then the ML5, again, is not a 60 gigahertz product. It's just regular AC rate to 5 gigahertz radio, and that'll give you up to 1,000 meters. All of them run on the same basic operating system, which, again, we've been selling these products for a little over 5 years now. So it's become very, very, I think, very, very user friendly and very functional operating system. Each of these devices has a UI built in for configuration and management and monitoring. All of our products support our cloud controller, but they're not required to be used on the cloud. So without a cloud controller, they will still function completely perfect. Jumbo packet support, management VLAN support with VLAN pass-throughs, link failover backup with 5 gigahertz we mentioned before, 128-bit AES encryption, and then dual firmware image support in case something does happen during a firmware upgrade or something. There's always a way to go back to the last version of firmware. So the operating system on these devices has become pretty evolved over the years for sure. The cloud controller, I mentioned, the cloud controller is free for the first 2 devices. It's free for life. Once you have more than 2 devices, you'll look to get an annual license, and that license is $99 a year, and that's for an unlimited number of devices. It doesn't matter if you have 10,000 devices, it's still just $99 a year. There's a couple of tools that we provide. If you go to the website here, cloud.ignitenet.com, and set up an account, you'll see a link path tool here. And this tool is really good for helping you plan out links. It lets you choose what device you're going to have on either side of a point-to-point connection, choose the channels you're using, the transmit power, the RAIN reliability in terms of nines, whether it's 5 nines or 6 nines or 3 nines. And what it'll do is give you a graphical representation of what throughput you can expect with RAIN and without RAIN, and what distance you'll get. So it's a really good tool for planning out the different network links, especially if you're going to mix and match, 35 centimeters and 19 in different sectors. So excellent tool. It's up on the website. It's free to use. Mounting brackets are the other things to talk about. All of our products, all of our point-to-point products used to come with a standard bracket you see there on the left. All of the products today do not come with brackets, so you'd have to choose which one you wanted. And there are people that love and hate either one of these. I'll tell you the benefits of the standard bracket are in adjustability. It's plus or minus 80 degrees of adjustability. So when you do a network and when you lock down your antennas on a pole, you have a lot of adjustability here. Its wind survivability is about 75 miles an hour. The precision bracket, the high precision bracket on the right, has less adjustability, so it's plus or minus 12 degrees. So you really got to be close to where you are before you lock it down. But what it does is give you much better wind survivability, 125 miles an hour wind survivability. So between the 2 brackets, we think that people usually choose whatever they're looking for. I'll tell you that I'd say 80% of our customers go with the high precision bracket versus the standard bracket. And then we have a couple of other tools that help you when you're doing connectivity. One is an alignment scope. If you're like me, I can't see a mile away when I'm on top of a pole. So the alignment scope is what you'd expect. It's like a rifle scope with crosshairs that helps you get into the general area from one antenna to the other. And then there's a link assist tool, which is an app that you download for Android or iOS devices. And you'd be able to use that link assist tool to finish the installation of the alignment to make sure that you're getting it as accurately aligned as you can. And that link assist tool only requires a USB Bluetooth dongle to be plugged into the device, which is available through Microcom. That we have one, but it's a standard USB Bluetooth dongle. You could, people find some on Amazon that are $4 and $6. But some of them, what we've learned is it's not a standard, and some of them work and some of them don't. So that's why we branded our own. But if you got the USB dongle, you could use the Link Assist tool to finish that alignment. If you don't have either of these tools, there's a web user interface on one of the radios on either end when you're on the tower or on a pole, and you could use that interface to actually do the alignment as well. The last product that I'll talk about here, I'll take questions. I'm sorry, it's going a lot longer than I thought. Maybe I'm talking slower today. This is a new product we just announced called G-Link. And what this is a coax. It's gigabit Ethernet over coax. And the reason why we announced this product, and I'll go right into the picture, we have a lot of customers that do point-to-point connections between buildings. And if it's an MDU or an apartment building or a hotel or something like that, the question always comes up, great, I got from one building to the other, but what do I do now to get through the building if the building isn't wired with Ethernet? So this G-Link product is based on the G.hn standard. And what it does is it lets you convert the Ethernet signal from the radio on the roof into coax and then use the existing coax cable throughout the building to get into different apartments or different hotel rooms and things like that. So it has a max speed of about 1.6 gigabits per second over that coax. And one of the really unique features is it has what we call reverse power. So the outdoor device that sits up on the roof by the Metrolink antenna could be powered by all the client devices throughout the apartment building or throughout the hotel. You have smaller little devices with antennas on them, like the one on the right. It has Wi-Fi built in, and then you could go from here. You plug this one, you power this device in the hotel room, and it'll provide power through the coax cable up to the roof. So it's kind of unique. And again, another comment or request from customers, because up on the roof, the last thing that they can do is find more power, right? The other interesting thing is if there's enough clients, the device will power the 60 gig radio as well. The device on the left is the outdoor unit, and it has a DC block port there. So you can provide power to the G-Link device on the roof and then also come out of this and power the Metrolink radio. So you won't have to worry about getting power to a rooftop where your other, say, end of your point-to-point 60 gig connection is. So it's kind of been a unique product. We'll be out at Wispapalooza next week, and we'll have some samples, and hopefully we'll be able to talk more about it and provide some information for anyone who's headed out to that show. And that's it. I'll take some questions.
Hey, Tony, thank you very much for that wonderful presentation. I could tell that everyone liked it. I've got a lot of questions for you. Let's go ahead and get started with the first one. It says here, being that the 5 gigahertz is the backup for 60, if it does fail over, how does one know that the 5 gigahertz will work in that environment? When you're running the initial check, do you check both frequencies?
Yeah, so that's a good question. When you set up the radios, you would set up the 5 gigahertz link as well as the 60 gigahertz link. You set a separate SSID and stuff. So you'll know where your 5 gigahertz radio is. And that 5 gigahertz link stays connected. It just doesn't pass any traffic. So you'd have to look at that and look at the channels that you're selecting when you do the installation to make sure that you're picking channels between the radios that are clean and not, don't have a lot of interference. But you would configure that during the setup itself. Yeah.
Thank you, Tony. Next question. Do you have competition with the 60 gigahertz? And if so, how does it compare to others?
Yeah, there are other vendors that are selling 60 gigahertz products for sure. Microtik is one of them that just launched the product. Ciclu is one of them that has 60 gigahertz products for some time now. So I would say the things that I think help our product stand out are obviously the built-in 5 gigahertz radio. We think it's real important, especially because the 60 gigahertz frequency is so susceptible to rain fade. If it starts downpouring, even that downpour rain can interfere with your 60 gig signal. So having the 5 gigahertz radios there as a backup, I think is really helpful. We have the cloud controller, which again, at $99 a year for more than 2 devices is relatively inexpensive, but it helps you know, and you could set alerts that something happened, or the 60 gig radio is down and it's now using 5 gig backup. So you need to know these types of things. So I think our cloud controller is a really good standout feature as well that we have versus others. I don't talk bad about other people's products. I think everyone has good products. I think there's enough market for everyone, but I think we have some features that make us stand out amongst the others for sure.
Excellent. Thank you so much for that. Next question. What channels are available on the 60 gigahertz?
Today, the product has 4 channels, and I could, if somebody sends me an email, you can get my email from Julie. I can give you the specific frequencies. I don't have them offhand. But I did mention the additional 4, the additional channels that the FCC opened up, and I did. Where today, within the 4 channels that we do have, we could go 1.7 kilometers, say. When they open up these new channels and we develop a new product that takes advantage of these higher frequency bands, that max distance can go from 1.7 kilometers to, that's about a mile. We can probably go almost to maybe 3 or 4 miles. So it'll triple the maximum distance of these products in millimeter wave when we start taking advantage of those higher frequencies. So to get the specific frequencies of the channels, if you email me, I could definitely tell you what that is. Sorry,
thank you, Tony. No problem. Oops.
There you go.
Thank you, Tony. If anyone needs your email address, I can certainly provide that.
Sure.
Okay, next question here. On the security image that you sent, so the Metrolink is capable of 90-degree area of connection or just 45?
So also, very good question. These are excellent questions. Thank you. So in this example, it depends on the radio that you choose. So in the example here where the lines are blue, if this was a 120-degree sector antenna, we can cover 120 degrees by 30 degrees with the main base station on the roof. And then the clients would still be their 2 or 3 degree beams back to that sector. So it depends on what you're doing. The blue could be a 10 gig Omni where you can get connectivity all the way around, or you could use a 120 degree sector to get just a portion of it like that building is doing now.
Thank you, Tony. Next question. How many antennas can you simultaneously connect on the Metrolink devices for PTMP connection?
Yeah, for point-to-multipoint, excellent question. So the sectors can support all 3 of the different point-to-multipoint sectors can support 8 radios. In fact, I might be wrong. I think we just released the software that takes that 8 to 12. So it's 12 per sector. So in the case of the LW and the Beamforming Sector, it's 12 clients. In the case of the 10 gig Omni, it's 12 per sector, so 36 clients.
Thank you, Tony. Next question here for you. Being easy to aim, is that going to cause easier interference on the links?
No. So easier to aim was the LW product. Because it's a 120 degree sector, it's easier to aim. So if you're planning out your deployments and you're within the 120 degrees, you're not putting something else on that same channel. Again, there's 4 different channels today. So technically, you could have 4 LWs going in the same 120 degree area on 4 separate channels and not see any interference. If you needed to reuse those channels, you need to be at least 2.5 kilometers away to start reusing those channels again. But you shouldn't see any interference from the devices themselves as long as you're 20 degrees away on the downside and pointing in the same 120 degrees on a different channel. So you shouldn't have any issues with interference that way.
Thank you, Tony. Next question here for you. Regarding direct line of sight and nothing in from the 2 units, does that mean weather and things like birds or squirrels being in the way? Would that block as well? I know it's a 1,000,000 to 1 shot, but sometimes that could happen.
No, it's a really great question. So, yes, yes and no. If you set up an antenna and in front of it is a perch where a bird could sit, then the answer would be yes. So if things are moving by quickly, you wouldn't see it. Ethernet is very forgiving, right? If it doesn't get an acknowledgement packet, it'll resend or ask to retransmit the last packet. So regular Ethernet protocols, I think, will help you with things that move by quickly like that, like a bird or something like that. But if it's set up in a place, and I laugh a little bit because we did a deployment with a customer down by a dock, and there was a radio set up, and there was a seagull that just liked to sit on top of the radio, and that thing was probably like 15, 20 pounds, and it kept moving the point-to-point client, and they couldn't figure out what was going on until they videoed, set up a camera to see what was happening and saw this seagull that kept sitting on the radio. So anything that's heavy enough to move the mount or the radio by more than, say, plus or minus 3 degrees is going to create a problem if it's there for a consistently long basis.
Thank you, Tony, for that. Next question here for you. With your tri-band devices, does it have any restrictions over other devices? And what if I connect to them to a non-IgniteNet device, connect via Wi-Fi, set it up as a repeater? Do we have reports on compatibility or talking issues?
Also a good question. So outside of 60 gig, which is proprietary, right? So somebody else's 60 gig radio wouldn't talk to ours. I mean, they're all loosely based on the 802.11ad spec, but they're all proprietary. The 5 gig and the 2.4 gig radios are just standard AC Wave 2 radios. So you could use another vendor's 5 gigahertz radio to connect to the 10 gig Omni or the LW, per se, as a client. And then under 5 gigahertz, it's a Qualcomm chipset, so maximum concurrent connections are about 128. So you get 128 5 gig devices and then 128 2.4 gig devices if you wanted to, from a Wi-Fi connectivity perspective.
Excellent. Thank you very much.
To answer your question, sorry.
Sure.
Sorry, just to answer the question, it should be interoperable with any standard 5 gigahertz client device.
Thank you again, no problem. Can you tell us about the warranty on these products, or different?
Yeah, IgniteNet standard warranty is 2 years, and it goes from our Wi-Fi products and our switch products all the way up to our 60 gigahertz products. So it's 2 years for all the products.
Excellent. Thank you very much. Let's see. It says your website, you've got some upcoming courses. Are there any plans on hosting them in California?
Yeah, so I believe that there are. I think we just finished the Train the Trainer with Microcom. I'd have to check, but we've created this Metrolink training program to be very technical and very in-depth, to cover everything from technology to installation to troubleshooting. And then we're training the trainers at our distribution partners. So I'll have to check and make sure that we've done the Train the Trainer for Microcom, and then Microcom should be scheduling trainings as part of their regular education offerings.
Great, thank you. And yes, the Train the Trainer is happening, so thank you for reminding us. Next question here. Is the scope needed at every link, or can the technician have one in the truck for all their installations?
Yeah, also very good question. And I don't just say that. These are really very good questions. So if you look at the top of this image, the top of the radios, the scope mounts on top of this, and then it's got thumb screws. So the idea is you just bring one with the technician, right? And he has one in his truck, he attaches it, he aligns it, and then he takes it off, and he does not leave it on the radio. So most technicians carry two just in case, they drop one from 100 feet or 300 feet. But yeah, you do not leave it on the link. You definitely want to take that down with you and only have a couple with you for alignment only.
Thank you for that, Tony. Can you tell us, if we need to reach you, at IgniteNet, can you tell us about your hours of support and what's the best way to contact IgniteNet?
Yeah, so I mean, we have support people throughout the U.S. and in Europe. So our U.S.-based team is based out of Atlanta. Actually, we have one guy in Pennsylvania too. So hours of operation are, say, 8 a.m. to 6 p.m. East Coast time. If you have a support question, the best thing to do is email support@ignitenet.com, it automatically generates a support ticket, and an engineer is automatically assigned. If you wanted to access or needed access to any kind of information after hours, you could email me and I will chase down anyone I need to make sure you get the answer you need.
Excellent. Thank you so much for answering all of those questions, Tony. And thank you, everyone, for attending today's webinar. If anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown here today, hopefully you can view them at www.microcom.us. Please remember this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel. So if you wish to view it again, you can certainly do that. Thank you, Tony, for your time and your presentation today. We appreciated every minute of it.
Thank you very much. And thank you everybody else for attending, and everyone have a really nice day.
Thank you, Tony.